Okay, so I'm going to talk you through the basic principle of sonar. Now, sonar is a way of locating objects by bouncing pulses of ultrasound off the object, and then by measuring the time it takes for the pulse to go from the transmitter and back to the receiver, we can work out where the object is. So a good example of this is the use of sonar by ships to detect, shall we say, submarines. If you're in a naval vessel and you're worried about a submarine that might be beneath you, then you might want to know its depth. And so the way that you can detect it is by firing pulses of ultrasound from your ship down through the water, and when it hits the submarine, the hard metallic surface of the submarine causes the ultrasound to be reflected. Essentially, you've got an echo, and the reflected pulse travels back. Now, obviously, the deeper the submarine, the longer it will take for the ultrasound to travel, and therefore, by measuring the time, we can calculate the distance. So, to work this out, we use the fact that in water, ultrasound travels at around about 1500 meters per second. And the equation that we use is a familiar one: distance equals speed times time. So let's do an example. Suppose you have a pulse of ultrasound which you fire from your ship, and 2 seconds later you hear an echo, you hear a bleep come back. So you know that your ultrasound has hit something and reflected back. How deep is that object? Well, if we use the equation distance equals speed times time, then we've got a time of 2 seconds and a speed of 1500 meters a second. So it looks like the distance is 3000 meters. And that's true, that is the total distance that the ultrasound has travelled. But remember, it went on a two-way journey. It travelled down through the ocean and then it reflected back up. So what is the depth of the submarine or the object that it reflected off? And the answer is 1500 metres, half of the total distance travelled, because it took an equal amount of time to go there and go back. So effectively the formula that we're using is speed, distance equals speed times time, and then we divide by 2 to find the depth of the object. So let me give you another example and see if you can work this one out. You might like to pause the video before I give you the answer. Suppose now that some fishermen are using ultrasound, using sonar, to try and detect whether there are fish beneath their fishing boat. And they fire a pulse of ultrasound into the water, and it's reflected back after 6 seconds. How deep are the fish? Okay, the data you need are a 6-second travel time and a speed of 1500 meters per second. All right, so pause the video, see if you can work it out, and then I'll go through the answer. So, first of all, we're going to use distance equals speed times time. The distance, the speed is 1500 and the time was 6. 1500 times 6 gives you 9,000 meters. That's the total distance that the ultrasound has travelled, but it isn't the depth of the fish. The depth of the fish will be half of that, so we divide by 2 and we get a depth of 4,500 meters. So now the fishermen know what position they need to put their nets in, how far down they need to go if they're going to catch those fish.